All, welcome to the Security Tube Linux Assembly Expert course and certification. Now in this video, we will look at the Hello World shellcode using the stack method. So what is the stack method? Now in the previous video, we used the jump call pop technique to find the address of the Hello World string in memory. Now, in the case of the stack method, we are just going to treat hello world as data and push it on the stack. Now, once that is done, getting the address of the string is super easy by referencing it with RSP. Now, once we have that, we can go back and typically do our hello world dance, right? Now, the important thing to remember is because the stack grows from high memory to low memory, our push on the stack of the hello world string would have to happen in reverse order, which means we first push in /n, then D, then L, then R, blah, blah, blah. And in the end, we push hello. So let's jump right in. I'm going to copy the basic hello world.nasm, which we created when we were learning the basics of assembly language. Let's just remove the comments. And we do not need the data section anymore. Now, I first need to convert the hello world string into hex bytes, but in reverse order. Now, this is where our best friend Python is very handy. So let me call this the banner. And here is my hello world /n string. And the length of this string is 12 bytes. Great. Let's reverse the string, and in Python this is super simple. Here we go. Here is the reverse string, and if we need to convert this into hex, that couldn't be more simpler. Here it is, right? We use the encode method along with the hex argument to encode this into hex. Now let's just go ahead and let's just go ahead and use this. So if you notice, RSI is the one which needs to contain the address of the string, while RDX is the length. The length we know is 12. And now let's go ahead and push this data on the stack. So we have 12 bytes. So here is one option. We can first do a direct push of 4 bytes. So here is 1, 2, 3, and 4 bytes. Now remember, you cannot do an immediate value push of 8 bytes. So we can do it in a slightly more roundabout way, which is first move this into RBX, which is not being used anywhere. Copy the 8 bytes out. And then go ahead and push RBX on the stack. Now we can reference the address of the hello world string using the top of the stack, which is RSP, right? Now the return value from exit basically can be 0. So we can actually remove this and make this XOR RDI RDI. Now there are going to be more nulls in this, but let's go ahead and find it out ourselves. All the moves typically would be nulls, but let's just view this real quick to understand what we are up against. So let's do a quick object dump -m intel -d hello world.o. You can clearly see the move has zeros in it. The moves again have 0 in it. So let's go ahead and fix this like before. So we could do a XOR RAX, add RAX1, move the value of RAX into RDI. Again, XOR RAX basically add 60 to RAX. Now let's try this out. We forgot the value in here. Move RDX part. So multiple ways. Let's just go the XOR way. XOR RDX. Then add RDX12. This should solve it. Sorry, I forgot to assemble. Yep, so looks like now we have eliminated all the nulls. Of course, you can keep shortening it. We'll talk about that much later, about how you can bring down your shellcode size. Right now, the focus is on creating non-null shellcode. So now, we can go ahead and use LD. Basically create the hello world program, and there you go, prints hello world. And now we can go ahead and dump this in shellcode format so that we can use with our programs. Copy the shellcode tester file in here, open it up, paste this inside, compile, and there we go, right? Run it. And this is how, using the stack technique, you can go ahead and create the hello world shellcode. Now the stack technique is very useful as well. The best part really is that here you don't have to jump through all the hoops to figure out the address. RSP itself just gives you the address of the string which you would like to use. So hopefully you've enjoyed this video at Pentester Academy. And if you like what we are doing, we would really appreciate if you can recommend us to your friends and colleagues in the InfoSec community. Thank you.